So, chapter three. What is chapter three all about? Well, in chapter two, we learned about chemistry. And in chapter three, we're going to learn about another subject called biochemistry. Biochemistry is kind of a hybrid between biology and chemistry. We're going to learn about the chemistry of life. So, in this unit, we're going to learn about things like proteins and carbohydrates. We're going to learn about nucleic acids and lipids. And we're going to learn about something called organic compounds. So, let's jump right in. So, what is an organic compound? Well, an organic compound is a molecule that has carbon and some other stuff. And unfortunately, there's not really uh, a set rule of what is exactly organic. So, for example, glucose is organic because it has carbon, but carbon dioxide is inorganic. It's not organic, even though it does have carbon. So, this is something you'll just kind of need to memorize, unfortunately. But the good news for you is that the four types of molecules that we care about the most carbohydrates, lipids, proteins, and nucleic acids are all organic. So, all of these are considered organic molecules. So, carbon is a very important element in biology. And what makes carbon so special is its bonding properties. Carbon has, as you can see, let's see here, this is a carbon, and this is a carbon that's bonded to one, two, three, four hydrogens. So carbon is really good at bonding to other atoms, and it can bond up to four other atoms at the same time. And this is because if you remember back to chapter two, when we talked about the outer valence shell or the outer shell of electrons, carbon wants to fill its outer shell just like every element does. But in order for carbon to fill its shell, it needs to bond four times, which is quite a bit. And that makes carbon very reactive and really good at bonding in a lot of different ways. So, some other important vocab here, besides organic compounds, is isomer. What is an isomer? Well, this is a word we're not going to use too much, but isomers have the same molecular formula, which means they have the same amount of each element, but they may have different structures. So, that's pretty much just a vocab word you can learn once, and you probably won't hear it too much anymore. Hydrocarbon, on the other hand, is a little more important. A hydrocarbon is any molecule that's made of only carbon and hydrogen. If it just has carbon and hydrogen, it's called a hydrocarbon. So let's take a look at an example of some different carbon-based organic molecules. Here we can see isobutane. Isobutane compared with butane, well, these are isomers. They have the exact same atoms, the exact same ratio, but you can see the structure of butane and isobutane is different. We can also look at something like cyclohexane and benzene. They have similar structures, but actually a little bit different with bonding. For example, here you can see that the carbons are double bonded. Every other carbon is double bonded. That's why there's two lines. But in this example of cyclohexane, they're single bonded. So just because they have a similar shape, it doesn't necessarily mean that they are isomers, or it doesn't necessarily mean that they function exactly the same. In fact, these two molecules are very different. So uh, if there's one line, that means it's a single bond. If there's two lines, it's a double bond. And carbon can bond to a maximum of four other atoms. So if we look at propane, this carbon is bonded to four things: carbon, hydrogen, hydrogen, hydrogen. If we look at this carbon, it's actually only bonded to three things: carbon, hydrogen, carbon. But in order to have a full valence shell, carbon needs to bond to four things. So this carbon and this carbon will bond to each other twice. And that means they are each sharing two electrons instead of each of them sharing one of their electrons.